Hello guys, welcome back to Math with Trockers. So today we are discussing vectors and we have a problem from ZIMSEC June 2016 paper 1. The question reads 15 item A, relative to the origin or the position vectors of P, Q and R are 2, 3, 4, 1, 0, -1 and -3, 1, -2 respectively. Find the angle PQR. B, the vector W equal to M minus half, M plus half, and M square root of 6. Item 1, if W is a unit vector, find the possible values of M. Item 2, the vector V equal to M plus 3, 2M, -2 square root of 6. If W is normal to V, find the values of M. Then lastly, item 3, the vector U equal to M minus half and 2 root of 6. Given that W is parallel to U, find the values of M and N. Okay, let's go ahead and get started. Okay, so firstly, guys, we are given the position vectors for the three vectors OP, OQ, and OR, right? So we can rewrite them as OP equal to 2, 3, 4, OQ equal to 1, 0, -1, and OR equal to -3, 1, -2. Right. Now we want to find the angle, the size of the angle. So we are going to use cosine PQR, right? So here, right, so we have our Q, right? We have our PR, right? So here we are going to use, so we need QP dot QR over their moduli. Right. Okay, so let's find these pieces first. Okay, so aside, so we need vector QP. So vector QP, it's head minus tail. So it's 2, 3, 4 minus 1, 0, -1, which is 1, 3, 5, right? And we need vector QR, again, head minus tail, which is equal to -4, 1, -1, right? And what else do we need? We need their moduluses. All right, so to find the moduli here, so modulus of QP is just square root of 1 squared plus 9 plus 25, right? Which is equal to 10 root of 35, right? Then we do the same, modulus of QR equal to square root of 16 plus 1 plus 1, which is root of 18, right? And now that we have all the pieces that we want, I think we are remaining with the dot product. So if I find the dot product, QP dot QR, it is equal to QP, that's 135 dot -4, 1, -1, which is equal to -4 plus 3 minus 5. -4 plus 3, that's -1 minus 1, that's -6. So now, okay. So now we have our cosine. So cosine PQR equal to the dot product over the modulus, right, 35, 18. So PQR equal to arc cos of that, right? Because of the negative, it is going to be an obtuse angle here. All right, so make sure your calculator is in degrees, not in radians. So you need to change that. Okay, so arc cos of -6 over square root of 35. Okay, square root of 35. Square root of 35 times square root of 18. All right, I'm getting 103, so which is 103.8302249. Right, so remember, if the degree of accuracy is not specified and if the answer is not exact, in case of angles, it must be estimated to be correct to the nearest whole number. So we have to leave it to the nearest whole number, which is 104 degrees, or I mean to the nearest degree. Right, so it's 104 degrees to the nearest degree there. Okay, so we are done with the first part. Now let's move to the second part. So on the second part, we are given vector W equal to minus m minus 1/2, m plus 1/2, and m root of 6, right? And we are further told that if W is a unit vector, find the possible values of m. So a unit vector is just a vector whose magnitude is 1. So here we know that magnitude is 1. So this implies that a square root of m minus 1/2 squared plus m plus 1/2 squared plus m root of 6 squared should give us 1. So if we square both sides, we're going to get m minus 1/2 squared plus m plus 1/2 squared plus m6m squared equal to 1. So if I expand first term squared, so it's going to be m, 2 times that, minus m minus 1 over 4, right? Plus 1 over 4, I mean, sorry. Then plus m squared plus m plus 1 over 4 plus 6m squared equal to 1. So here, this and that will cancel out. So we have 6, 7, 8. So we have 8m squared. That's 1/2 equal to 1 minus that, right? So 8m squared equal to 1/2. M squared equal to 1 over 16. So m is equal to plus or minus square root of 1 over 16. Therefore, m is equal to plus or minus 1 over 4. Right. So we are done with this problem. M is equal to plus or minus 1 over 4. All right. Moving on to C. So on C, we are given that V, so vector V is equal to m plus 3 2m minus 2 square root of 6, right? And remember, vector W is equal to m minus 1/2, m plus 1/2, and m square root of 6, right? Then for this question, they are saying if W is normal to V, find the values of M. So when two vectors are normal or perpendicular to each other, their dot product is 0. So here, V dot W should give us 0. So this implies that M plus 3 2m negative 2 root of 6 times M minus 1/2 M plus 1/2 m root of 6 is equal to 0. So let's go ahead and multiply. So I have m plus 3, m minus 1/2 plus 2m, was it 2m here, times m plus 1/2, then minus 2m times m root of 6. We should get 0. So if I expand, if I distribute here, m squared minus half of m plus 3m minus 3 over 2 plus 2m squared plus m minus 2m squared square root of 6 is equal to 0. I think I omit. Okay, sorry. Here it's supposed to be not 2m, but this is supposed to be, it's minus 2 root 6 minus 2 root of 6 times that. So 6 and 6, that's root 6 times root 6, that's 6 times that, minus 12m equal to 0. All right, let's simplify. All right, so when simplifying this and that, that's 3m squared, right? We have minus 1 over 2m plus 3m, right? Okay, let me just say plus, sorry. Let me just say plus, okay. So minus this half of m, right? 3 plus this plus 4m, right? I have negative 12, okay, minus 12m as well, minus 3 over 2 equal to 0. Okay, let's simplify further. So I have 3m squared minus 1 over 2m, 4 minus 12 minus 8m minus 3 over 2 equal to 0. I can multiply everything by 2. So I have 6m squared minus m minus 16m minus 3 equal to 0. So I have 6m squared minus 17m minus 3 equal to 0. So we can factor this out. So we have, that's negative 18, and factors of that is negative 18 times positive 1. So it's 6m squared minus 18m plus 1m minus 3 equal to 0. So 6m, then m minus 3 plus 1, m minus 3 equal to 0. So 6m plus 1, m minus 3 equal to 0. So therefore, m equal to negative 1 over 6 or 3, right? Or 3. So these are the possible values of, actually these are the values of m in this case. All right. So now we are moving on to the last part of this problem. All right. So the last part, we are given vector u equal to m minus 1/2 n 2 root of 6, right? And also here we are told about vector w. Remember, w is m minus half, m plus half, m root of 6, right? So the question reads, given that w is parallel to u, find the values of m and n. So when two vectors are parallel, it means their direction vectors are scalar multiples.
So guys, we have to understand that two vectors are parallel if they are scalar multiples of each other. And if they are scalar multiples, then their components are in the same ratio as well.
So what it means is that this vector u here, right, is equal to k or lambda vector w. So I will take m minus half n 2 root of 6, right, is equal to k, then m minus half, m plus 1/2, and m root of 6, right? Since these are scalar multiples, guys, it just implies that k of m minus half is equal to m minus half.
So guys, remember what I said earlier on, that their components are in the same ratio. So in this case, I will consider the first component since both vectors have m minus half.
So if I divide here, k is equal to what? K is equal to 1. So when k is equal to 1, then this implies that n equal to m plus half. That's equation 1. right? And also 2 root of 6 equal to m root of 6, that equation 2. So from 2, so therefore m is equal to 2 from this part. When m is equal to 2, n equal to 2 plus 1/2, which is equal to 5/2 or 2.5. So okay, so lastly, let's just say m is equal to 2 and n equal to 2.5. Right. So guys, that's all about this problem on vectors. Let's continue to do more practice. I will see you in my next video. Take care.